In this video, we will learn about static and dynamic memory allocation. So these are the topics that I'm going to cover in this video. I'll discuss about the memory, how the memory is utilized, how it looks like. Then we will see how a program uses the main memory, how the program will utilize that main memory. Then we'll see static memory allocation, that is static allocation, or dynamic memory allocation. So these are the topics we'll discuss. Let us start by studying something about main memory. Let us discuss static versus dynamic memory allocation. So for that, we should understand memory. Suppose this block shows a memory. This is a memory. So the memory is divided into smaller addressable unit that is called as byte. So memory is divided into bytes. So these boxes, these check boxes, let us assume those are bytes. And this is the entire memory. A small picture I have taken. Every byte is having its address. Let us say the address of this is 0 and this is 1, this is 2, 3, 4, 5 and this will be 6 and 7, 8, 9, 10, 11 and 12, 13 goes on. So I am starting from the bottom. One thing to observe is that diagram I have drawn as a two-dimensional, but the addresses are single dimension addresses, linear addresses. So address will have just one value, not like a coordinate system x comma y, it will have a single value. So addresses are linear. After this byte is 5, then this is 6 and 7 and so on. So it depends on the size of the memory, every byte will have its own address. So if I take a bigger size of memory, let us say this is a memory, and then this cornermost byte address is 0. So let us assume that this cornermost byte's address is 65535. So total 0 to 65535 makes 65536. So total number of bytes are 65536. This is nothing but 64 into 1024. So this is 64 kilobytes. So in my entire discussion, for the entire discussion of the subject, I'll be assuming that the size of the main memory is 64 kilobytes. Okay, let us make this assumption. The size of the memory can be anything. Nowadays we are using memory in GBs, like 4 GB, 8 GB memory we are using. But to understand, we have to take a small part of main memory. So I am taking 64 kilobytes of memory. So the first address is 0 bytes and the last address is 65535. So total 65536, that is 64 into 1024, so it is 64 kilobytes. So this main memory is of 64 kilobyte. Every byte is having its address, like how I have shown you here. In our computers, if you have larger size RAM, that is 4 GB or 8 GB, that entire memory is not used as a single unit, but it is divided. It is divided into manageable pieces that are called as segment, and usually the size of a segment will be 64 kilobyte. So I am talking about a segment. So in our discussion, always we'll assume that the size of our memory is 64 kilobyte, that is we are talking about a segment. Now next we have to understand how a program uses main memory. Now let us see how our program utilizes main memory. This picture shows this block, entire block from this corner to this corner is a main memory. Assume that this byte address is 0 and this cornermost byte address is 65535. As I said, we'll be taking one segment of memory and studying it. So this entire main memory is divided into 3 sections and used by a program. So I'll label the sections. One of the section where the program resides is called as code section. And one of the section, usually this is the section, this portion is called as stack. And this remaining portion is called as heap. But I'll just change the side because it is easy for me to discuss. If I call this portion as stack and this portion as heap. So a program uses the main memory by dividing into 3 sections, code section and the stack and the heap. I am showing stack at this place. Now I'll explain how a program uses these 3 sections. So let us see. See here I have a program file on the hard disk. If I want to run this program, so this program the machine code of the program first should be brought inside the main memory. So it is brought inside the code section. So let us say this is a program or the machine code of a program. So the area that is occupied by the program in the main memory, that section is called as code section. That may not be fixed, it depends on the size of a program. So this is the code section area where the machine code of a program is loaded. Now once it is loaded, the CPU will start executing the program, and this program will utilize the remaining memory as divided into stack and heap. Now let us learn how this stack and heap works. So I will take the example code and I will show you how stack memory is used and how heap memory is used. I have taken an example code here. See, this is my main function. It's having two variables. One is of type integer, the other one is of type float. Now I will assume here, listen carefully, I am assuming here that integer takes 2 bytes and float takes 4 bytes. In C++ programming, number of bytes taken by integer depends on the compiler and the operating system and the hardware. It depends on various things. So we say mostly depends on the compiler. So integer may take 4 bytes also, 2 bytes also. Okay, so 2 bytes is easy for explanation purpose, so I am taking integer as 2 bytes. If you take Turbo C, which is a 16-bit compiler, it takes 2 bytes for integer. Usually if you use Dev Studio or code blocks or anything, then integer will take 4 bytes in that one. So it's a 32-bit compiler. Alright, so integer can take 2 bytes also, 4 bytes also in C++. Got it? So I am assuming integer takes 2 bytes and float takes 4 bytes. Now let us come back to the point that we were discussing. We were discussing how this heap memory and the stack memory is used by the program. So let us see. I have these two variables, 2 bytes and 4 bytes, total 6 bytes of memory. In the program it is written that it needs 6 bytes. So that 6 bytes of memory is allocated inside the stack. Inside the stack. So let us show it as separately. So this is 2 bytes and this is 4 bytes. So these 6 bytes are given to the program, and this is nothing but a main function. I am showing only main function. So this block of memory that belongs to the main function is called as stack frame of main function, or it is also called as activation record of main function. Activation record of main function. So one thing we learned that whatever the variables you declare inside your program or inside a function, the memory for those variables will be created inside the stack. This portion is a stack. So it allocated inside the stack. So the portion of memory that is given to the function is called as activation record of that function. So how the memory is allocated inside the stack, it depends whatever the variables you have inside a function. So the size of the memory required by a function was decided at compile time only. Compiler will see that this needs some bytes and this needs some bytes, so it will beforehand decide that this function needs so much memory, and that memory is obtained once the program start executing. It is obtained inside the stack. So we say this is static memory allocation. What is the static here? How many bytes of memory is required by this function was decided at compile time. So it is static. So what is static? The size of the memory is static. When it was decided? Compile time. So when anything is done at compile time or before runtime is called as static. So this memory allocation is static.